Hello everyone, my name is Arya Salvi, a final year BTech student from the Department of Cybersecurity at GHRCEM College of Engineering, Pune. I, along with my team members Rushikesh Patil and Atharva Deshpande, have developed a project titled Preventing DoS and MITM attacks on sensors used in smart cities. Under the esteemed guidance of our mentor, Mrs. Masira Kulkarni ma'am and Mr. Supratim Manna sir, and our HOD, Dr. Deepika Azarkar ma'am, and Major Project Coordinator, Professor Rupali Patil ma'am. So, this project focuses on protecting sensor networks in smart environments using a Raspberry Pi. It passively monitors the network for suspicious activity such as high-rate DOS floods or ARP spoofing attempts and reacts instantly. Unlike heavy enterprise tools, it is lightweight and designed specifically for small sensor setups. Our motivation was the growing vulnerability of sensor networks. They often operate in open, unsecured spaces and use lightweight hardware that cannot run enterprise level security. For example, a single compromised node can flood the network or spoof the gateway's MAC address. This project fills that gap by providing a fast, lightweight protection system running directly on a Raspberry Pi. The core problem is that sensor networks have no built-in protection against DoS or MITM attacks. Floods can overwhelm their limited bandwidth, and ARP spoofing allows attackers to silently intercept traffic. Since these systems are small and resource constrained, they need a lightweight on-device detector, which is exactly what our project provides. Here are some key objectives listed based on the problem statement. To design a lightweight security system that detects DoS and MITM attacks on sensor networks in real time. Second, to monitor network traffic efficiently using resource-friendly techniques suitable for smart city sensors. Third, to identify spoofed MAC/IP behaviors through intelligent ARP and packet rate analysis. Fourth, to automatically block malicious devices and preserve normal sensor communication. So in our next section, I will provide you a short summary of our poster containing the sections methodology, scalability, and innovation. In methodology, we capture live traffic, extract simple features, and run a pre-trained ML model to detect attacks and automatically block malicious IP with IP tables. In scalability, one Pi is enough for small networks. Multiple Pis or cloud dashboards can be used for larger deployments and centralized updates. In innovation, we have done cost-effective on-device ML inference, modular design for new attacks, and automated dynamic blocking, making AI-driven defense feasible in resource-constrained IoT setups. The practical takeaway from our project would be that it provides a cheap, portable Raspberry Pi sensors which can provide real-time ML detection and automated response for local networks without heavy hardware. Now I will show you the implementation part of our security system. So as you can see, here we have two windows. One is of Kali Linux and one is of Raspberry Pi. Kali Linux is used to perform various types of attacks, and we will be using it to perform denial of service and man in the middle of attack on the Raspberry Pi. Here the Raspberry Pi acts as the victim and is viewed remotely on the laptop by the software called Real VNC Viewer. Here we have set up all the commands necessary for the attack. Now I will tell you briefly what denial of service is. Denial of service attack is an attack in which the attacker sends large number of packets to the victim, which overwhelms the victim's server and temporarily disables the services available on the server or the target. So now I will tell you the command used to perform attack on the Raspberry Pi. Here is the command sudo hping3 -s space -- flood space -p space 80 space 192.168.43.238. Here hping3 is the command used to perform denial of service attack on the Raspberry Pi. -s indicates SYN request. Minus minus flood indicates flood type of attack. Minus P80 represents port 80 and 192.168.43.238 indicates the IP address of the Raspberry Pi. Here we have the command for detecting the DoS attack on the Raspberry Pi. Sudo is used for administrative permissions in the Raspberry Pi. Python 3 is used for executing the Python file uvf4.py, which is our detector. Minus minus if phase WLAN 0 is used for mentioning the Wi-Fi interface of the command. Run DOS is used for running the DOS detector on the Python file. The gateway IP 192.168.43.1 is the IP of the router. Known GW MAC F2 9B6C460D54 is the MAC address of the router. Whitelist 127.0.0.1 and 192.168.43.238 are the respective IP addresses of ETH0 of Raspberry Pi and WLAN 0 of Raspberry Pi. These are whitelisted so that they don't get accidentally interfere in the detection process. Now we will execute the command on Kali Linux, which will initialize the attack on the Raspberry Pi. So as you can see, we have to enter the password for the sudo, which is the administrative permission for the attack. As you can see, it is in flood mode and now lots of packets are being sent to the Raspberry Pi. Now we will start the detector on the Raspberry Pi so that it detects the attack. So as you can see, there are a lot of things here. We will go by one. So here you can see it has started TCP dump on WLAN 0. This acts as a starting point for the detector. It analyzes the traffic on the Wi-Fi interface WLAN 0. As you can see, a couple of packets have been already transmitted before the attack. The source is mentioned as 192.168.43.79 and 43.33. These are ordinary packets. As you can see, the rate is quite low. One is 2 packets per second and one is 79 packets per second. We have set the threshold for 200 packets per second to be able to classify as a denial of service attack. As you can see here in this command, the rate becomes too high, almost 1500 packets per second. This obviously crosses the threshold and triggers the detector for blocking the attack. So as you can see, here it has mentioned it has exceeded the threshold and has initialized the detector and the blocker. The blocker inserts drop rule for this IP. The drop rule is basically an IP table drop rule which is used to classify this IP as a malicious IP and drop it. Here we can also see the forensics reports have been generated at the particular location. We will view this at the end, and further monitoring of further sources and further rates of packets are mentioned here. So now we will stop the attack and now perform the man in the middle of attack or MITM attack. Man in the middle of attack is the kind of attack in which the attacker pretends to be another device and fools the victim device. Here is the command used for performing the attack. Sudo arp spoof -i eth0 -t 192.168.43.238 and 192.168.43.1. ARP spoof is the main command used for spoofing the ARP packets. -i eth0 is the part of the command used for mentioning the network interface, which is the Ethernet. -t defines the target. 192.168.43.238 is the target and the victim, and 192.168.43.1 is the attacker, which will send fake ARP packets from a fake MAC address in order to fool this victim. Here is the detector command used for detecting and initializing the MITM detector and which will help block the attack from the attacking machine. It is the same as the denial of service command, except here we can see it is running the ARP portion of the detector. Everything else is same, and this is the MAC address of the original router. So now we will execute the commands and see its effects. So as you can see, we have started the attack and it has already started to fool the victim and manipulate and send fake ARP packets. Now we will start the detector in order to detect the fake ARP packets. Here we can see the TCP dump is initialized so that the detector has started. It has shown some warnings which shows us that gateway 192.168.43.1 is claimed by this MAC address. This is a fake MAC address generated by the attacker machine in order to fool the user. It warns 3 times before blocking it. So as you can see, it has blocked using EB tables. EB tables is basically the tables used for storing MAC addresses when they are blocked. So as you can see, this command, this particular statement has blocked this particular MAC address, which is a fake one generated by the attacker machine. Accordingly, the forensic report is generated. And here we can also see that a second MAC address is also blocked. 2A BA C6 22 C1 2D. This is the second MAC address which is also fake generated by the attacker machine. The attacker machine does this to fool the victim, which creates a confusion and may confuse the detector. But our detector is very advanced and detects the fake MAC addresses and blocks it in time. So it has blocked this MAC address and now its forensic report is also stored. And further, it monitors for any suspicious activity. Now, in this third part of the video, we would show you the generation of forensic report. So as you can see, the cat command is used to locate the relevant JSON file stored in the relevant directory. This is stored automatically during the attack. The JQ portion of the command is used for executing the JSON file. This particular forensic report is generated using an API which is connected to Qwen open source software. The Qwen AI is an open source AI which is available online and it is called remotely by the detector through an API which extracts the relevant information from the attack and prints it into a relevant format for security systems, security personnel to analyze and further steps and directions. So as you can see, in the denial of service attack, the correct detector, DoS detector, is triggered. Its severity is mentioned as high. The action is performed as blocked. The source IP is mentioned. The protocol is mentioned as other, which includes all the protocols involved in the denial of service attack. The packet rate is mentioned as 1585, which is well above the threshold of the denial of service detector which we have used. The bytes rate is not computed because the rate is too high for it to compute. It has started at this particular time and it has blocked until this particular time. Some relevant nodes are generated and a unique event ID is generated. The same is generated for the MITM attack, in which the relevant MITM detector is triggered. The attack kind is mentioned as spoofing, the severity is mentioned as high, and the relevant action block has been done. The MAC address, as you can see here, it has blocked the fake MAC address. The IP from which the MAC address has been done is also mentioned. The expected MAC address was the real MAC address of the router. Hence, because of this, we can successfully say that this is the fake MAC address. Here are some key metrics being mentioned, such as the ARP rate per second, distinct IPs in window, and window per second. The required time is mentioned along with some notes and event ID. And here is the report for the third MAC address, which is the same as above. Thank you.